This is the video for Algebra2B, Part 16, Task 1, Complements. So let's review probability. Probability is how likely something is to happen. What are the chances of this occurring? When you calculate probability, probability is always a number between 0 and 1, so it's usually a fraction or a decimal or a percent. To calculate probability, you find the number of ways it can happen Another way to think about that is favorable outcomes divided by the total number of outcomes. So for example, if we rolled a 6-sided die, so a regular standard die, what is the probability of rolling an odd number? Well, when we roll a die, we have 6 options. We could get a 1, a 2, 3, 4, 5, or a 6. So that means when we calculate our probability, the total number of outcomes, so the bottom number is 6. The top number is the number of ways that we can get an odd number, the number of ways it can happen, the number of favorable outcomes. Well, of these 6 numbers, 1 is odd, 3 is an odd number, 5 is an odd number. So 3 out of 6 is our probability. You can reduce that. 3 goes into each, so 3 divided by 3 is 1, 6 divided by 3 is 2. So 3/6 or 1/2 is our probability. In this lesson, your focus is to calculate the complement of an event. So the complement of an event are all the outcomes that are not the event. Okay? So it's sort of like the opposite of the event you're talking about almost. Together, the event and its complement make all possible outcomes. The probabilities of the event and its complement, then, because it's all possible outcomes, they add to 1. So there's a formula for this. If they add to 1, then finding the probability of the complement of an event, say A, is 1 minus the probability of event A. Now you'll notice here I have a little note about the notation here. P of A to the C really means the probability of the complement of event A. So the C indicates you want the complement of whatever the event A is, and P of A just means the probability of event A. So let's think about this. Events that are complements. Let's stick with the die. If we roll a 1 or not rolling a 1. So everything else basically. So rolling a 2, a 3, a 4, a 5, or 6. Those are complementary events. Those are complements. An example that aren't complements, let's stick with the die. If we roll a 1 or roll a 2. Those aren't complements because there are other options. We could still get a 3, 4, 5, or 6. So rolling a 1 or rolling a 2, those are not complementary events. Let's look at some examples. So the probability that you win a certain game is 1/3. What's the probability that you don't win the game? Okay, So winning the game and not winning the game make up all the possibilities, make up all the possible outcomes. And so these two events are complements. So what we can do is we can take 1 minus the probability that we do win. And that will give us the probability that we don't win. So what's 1 minus 1/3? 1 is really 3/3, same as 3/3. So what's 3/3 minus 1/3? Subtract the numerators. 3 minus 1 is 2. Keep the denominator the same. So 2/3. Example 3 has the problem written in our sort of probability notation. So we know if the probability of A is 0.64, what's the probability of the complement of event A? So probability of the complement of A is 1 minus the probability of event A, or 1 minus 0.64. And 1 minus 0.64? 0.36. In a recent election, 35% of the voters were Democrats. What is the probability that a voter was not a Democrat? So again, being a Democrat or not being a Democrat consists of all the possibilities, all the possible outcomes. So we can just simply subtract that 35% from 1. Now, we don't want to do 1 minus 35. Anytime you're given a percent, you want to change that to a decimal. So 35% is 0.35. 1 minus 0.35 is 0.65. So 0.65, or we can convert that back to a percentage. There's a 65% chance that the voter wasn't a Democrat. All right, that's it. Now you can go on and try the practice problems.